We set up the procedure with paper towels, a monster can, a Cheeto, and a metal ring clamp. We chose a Cheeto, then measured its mass. We took the Cheeto and punctured it with a large paper clip. We placed the monster can on the metal ring clamp and placed the punctured Cheeto under it.
We placed them in the indoor heater and lit the Cheeto on fire. It took the Cheeto 2 to 3 minutes to be charred and completely burnt. We then took it out of the heater and carefully measured its mass again. We took the first mass and subtracted it from the second mass. We then got the mass that would be calculated to find the calories inside the Cheeto. In the end, we calculated 150 calories in one Cheeto.
Also, we calculated our percentage error. We did the theoretical value minus the actual value divided by the theoretical times 100, which the percentage error was 56.66%.
Experiment number 1, we used baking soda and acetic acid. First, we carefully measured 10 grams of baking soda in a plastic container. Then we placed it into a 50 milliliter of acetic acid into a 400 milliliter beaker. We started with the initial temperature of acetic acid of 21 degrees Celsius, and the final temperature resulted in 16 degrees Celsius. The baking soda and acetic acid reacted to each other immediately, creating bubbles, and delta T was negative 5 degrees Celsius. Delta H reacted negatively, causing it to be an exothermic reaction.
Experience number 2, we used calcium chloride and 50 milliliters of water. First, we set up for the experiment. Next, we went and placed 8 grams of calcium chloride in the plastic container. And we poured 50 milliliters of water into a 250 milliliters Urban Meyer flask. We poured the calcium chloride into the water and stirred it until it completely dissolved. After 15 to 30 seconds, we took the temperature of the surface. We started with a temp of 21 degrees Celsius of the water, and the final temp was 33 degrees Celsius, in which the delta T was 12 degrees Celsius. Also, delta H reacted positively, causing it to be an endothermic reaction.